You want to see if the given series is conditionally convergent, absolutely convergent, or divergent. So the first thing, notice that we're dealing with factorials and we're dealing with um, exponents, right, in some ways. So we have to use the ratio test for this, right? The ratio test will involve taking the absolute value, right, the limit of the absolute value of the ratio of the next term of the sequence divided by the current term of the sequence, right? Okay, so let's see. So since we're dealing with absolute value, this can be disregarded because this will become positive. -1 will become +1. No matter what the k value is going to be, 1 is going to stay 1, right? And the absolute value of this is going to be still absolute value. I mean, it's not going to change, right? So we can let go of the bars. It will be the same, k to the 10th over 2k factorial, right? So let's see. So let's get straight to the point. So the next term is going to be k plus 1 to the 10th power divided by, now k plus 1 will be, k will be substituted with k plus 1. K plus 1 will multiply the 2 in parentheses, right? So we're going to get 2k plus 2. Be very careful. Not 2k plus 1, but 2k plus 2, because 2 will multiply the 1 as well. So 2k plus 2 factorial. So now this is the next term of the sequence, right? We have to divide it by the current term, which is this one. So we're going to instead multiply and flip this guy, right? So 2k factorial divided by the former numerator, k to the 10th. Okay, so let's see what's going on. There's lots of things that we need to probably simplify and cancel out. Let's see what we get. So let's keep k plus 1 to the 10th power. Let's keep 2 to the k 2k factorial in there, and then 2k plus 2 factorial can be interpreted as 2k plus 2 multiplied by 2k plus 1 multiplied by 2k factorial, right? So that's how you factor out the two factors so that you have 2k factorial times k to the 10th power. Right, so let's see. So what's going to cancel out? These two guys will definitely cancel out, right? So now let's actually see what we're going to do. So we're going to get k plus 1 to the 10th over, and we're going to have to actually multiply everything for 4k squared times k to the 10th, so 4k to the 12th, right? Plus 4k. I'm sorry, no. 4k plus 2k plus 4k. So that's 6k, right? 6k times k to the 10th is 6k to the 2k, 4k, 6k, k to the 11th, right? And then plus 2, right? Plus 2k to the 10th. So now, as you can see, we're gonna multiply the numerator denominator by the k with the highest power. K with the highest power is k to the 12th, right? Because if you expand this, you will get k to the 10th as the highest, right? So we have to multiply by 1 over k to the 12th, right? Both the numerator and denominator, 1 to the power of k to the 12th, right? So what are we going to get? So as you can see, and I'm gonna get straight to the point. So as you can see here, when you plug in the infinity here, you will have something in the denominator left, right? So basically what you're going to have when you evaluate the limit, you will have something over infinity in the numerator, right? So you're going to have 0 in the numerator, right? And in the denominator, you're going to get 4, right, plus 0 plus 0, right? So 0 over 4, which is equal to 0, right? So the ratio test tells us that it's going to be 0, which is less than 1, right? So if it's less than 1, then we have absolute convergence of the original series, dictated by the ratio test. Thank you so much for watching, and I'll see you in the next video.